Hello everyone, my name is Prakash. I'm here to explain the time series project which utilizes this particular data set, which is monthly beer production. So without delaying, let's start. So import from starting, we are importing the Pandas library and just reading our data set. So we use this function read CSV to read the particular CSV file we want to do the time series analysis. Now doing some basic like EDF. So we are doing df.head, df.tail. So these are steps. Basically, we want to see how, like, what kind of data actually we have, what we have to deal with. So going through it, we are able to see like this is the month column which have type of dates, and this is the column where we have float values displaying the production of the beer. Okay, so now next is thing is to check like whether is there any null values or not. So using this dot is any function says if that particular column has any null values or not. So without this count we actually get what, like if we remove this count. So when running this df dot is any, we will actually have the full like particular row, each row, and have the false or true. If there is true, means there is a null value. If there is false, then we have say null, not null value, like there are no null values. So rather than like going through each rows for this all data 475 rows, we can directly say count. So if there would be null values, the count would be shown here. There are no null values, so we are counting that part. So it's 476, so that there are no null values. So we are perfectly fine now. And yeah, as we have seen, like it's a kind of string, not a particular date format we have here. So we want to tell our data frame like no, we have to treat it as a date only. So what we are doing, like that month column needs to be changed into the date format. So we use utilizing pandas libraries dot to date time function. Okay, good. So we are doing it here. Then what we are doing is setting the index for that particular month. So that particular month needs to be set as an index so that when we are like doing our time series for data analysis, we should have an index column. That's requirement. So we are converting that with this method dot set index. If you hover this, you can see like it's set the data frame index using existing column, set the data frame index. So yeah, once the index is ready and we are having the date time column perfectly fine. So what we're doing, just now seeing like how data is look. So now you can see month column has exactly the dates for each month from 1956 till end. So you can see they're slightly like the columns are not aligned correctly, like month is downwards and monthly beer production is upward. So this actually occurs when we set the index. So this is displaying like yeah, month column is an index, this is not an index, monthly beer production. Okay, so moving ahead, we want to have some statistical insight about our data. So div data describe when we do, we actually have this data like 476 rows we have, like mean values for the beer production is 136. What's the standard deviation and all. So minimum value you can see it's 64, like from 64 it started somewhere, and what's the highest value we are dealing with, it's 217. So these kind of details also help us like to in cleaning the data. Also it helps like we want to normalize in some case our data, we want to transform it. So whatever we want we can do from this. Here we can get the insights. Next thing is, as we are going with time series part, so actually we actually need to have a first step ready, that is to check whether our data is stationary or not stationary. So our ask is like data should be stationary, like there should be some patterns, but what we want is to make the data first non-stationary. So non-stationary doesn't mean we have to finally deal with non-stationary data and then forecast. No, non-stationary basically means splitting the trends and patterns. So sorry, trends and patterns till random values are left. Means just suppose there were some spikes and spikes by like there is a some type of pattern in our data, and we want to split those patterns, trends कब तक रिमूव करना है, जब तक कि हमारे पास रैंडम वैल्यूज वाली चीजें ना बचे, लाइक विच आर नॉट द पार्ट ऑफ ट्रेंड्स एंड पैटर्न्स. सो वी वांट दैट पर्टिकुलर थिंग, एंड देन फाइनली वी कैन डील with only stationary part. So just plotting this, I can show you, like you can see they are not direct spikes. There's some noises, or we can say there is some non-stationary data, though they are appearing to be in pattern. Exactly, yes, they are in pattern, but what we want is to deal more accurately. So next thing is doing to get more insight, like whether we have to deal with whether we are dealing with any seasonal kind of data, or we are dealing with any some trends only pattern. Oh, yeah. So here what I have done is that multi pair production column I want to resample is in what way I have to resample .QE. So there are many more aliases, like for a particular day if we want to do some analysis, so we have to use D, and for hour we have R, H alias. So here what we are doing quarterly analysis. So converting my data, like which was of 12 months, I want to convert into quarters. How many quarters we have? I want to convert, it's 2 quarters. And E is stating like the dates of each month should be the last date. If we use S, it's the starting date. So in the documentation, it's like currently QE is supported only. So end date is beneficial. So we have done this QE, and dot sum is indicating for those 6 month values of beer production should be summed up and then displayed against them. So you can see like 1956 third month till 1956 ninth month. We have 6 month data, and that value is 284. So we have done from list large data into the smaller sets. Only 5 rows we have. Okay. So next what we have, like yeah, now plotting the graph again. Now to see like what kind of data we have. So you can directly see spikes down, spikes up, spikes down, spikes up, spikes down. So what this is suggesting, like in 1960 we have this part. So earlier this production was low. Whenever that particular month hits, like till that particular month where it was low to till that particular month where it was high, means it kinds of seasonal type of thing. Means we can say in summers it was gradually increasing, and from winters it gradually it start gradually decreasing, or vice versa. So we can make some of type of analysis. Yeah, we are dealing with any kind of seasonal type of data. So once we are get to this insight, now we want to verify what we are feeling, what we have intuitions we want to verify. So we are using stats model, which have one method like ADfuller. There are other method also, like I think KB method is also there, and 2 to 3 more methods we have. So ADfuller method currently we are using. So what we want to check is our data is stationary or not. Though we have made some intuitions while looking at the graph, but we want to verify through statistics. So using ADfuller method I am doing. Now what we want is, first we can see like what's the property of stationary. So stationary data actually have the mean and variance along with the autocorrelation part. Like they does not change over time. This shows some of the patterns over a period of time, maybe 1 year, 2 year. We have some patterns again, similar kind of data spike data is repeating. So initializing the ADfuller method to check whether we are right or wrong. So it starts with through mathematically, like getting a null hypothesis. We are assuming null hypothesis like it is non-stationary. We are saying like yes, our data is non-stationary, and the acceptance hypothesis is it is stationary if null hypothesis is rejected. What the condition to check is, like we have a p-value. I'm explaining it below, like what's the p-value is exactly. So for p-value, if the p-value is less than 0.05, means we have stationary data. Okay, remember, like p-values should be less than 0.05. If it's greater than 0.05, we can say like yeah, our data is non-stationary. So yes, and actually what is our ask, we want to like see is our data is stationary or not. Okay, so again now we are testing it, initializing. So yeah. One thing is there, like currently we know we are dealing with seasonal type of data. So it will this results if the p-value is, like you can see here, is negative 2.23, which is stating like, yeah, our data is like non-stationary. Okay, and if it's non-stationary, so we want to make it stationary basically, you know. So what we want to do is, now if we were dealing with seasonal type of data, okay, so we know we have to do seasonal differencing. If you're not dealing with similar kind of data, we can use this log transformation differencing only method. Like differencing only means like shifting our columns by one to whether according to our requirement, and detrending, like if there is a trend. So these are some kind of methods along according to the data we can use. So we know that if we are using this dealing with seasonal type of data, so we are using seasonal differencing transformation. What it means is we are creating a new column named seasonal sales difference, and we are doing monthly DVR production column minus, like the original column which we have here, minus DF monthly DVR production shift to 12. So this shift 12 is basically indicating us like our, like we have monthly type of data, so they are 12 months. We want to shift that those 12 months, like 1 year data forward, and then we want to subtract them just to see like seasonal difference what we have over a year of time. So similarly, like if we have a daily data, we can shift it by one. So after 1 day we want to see 2 days, weekly we can do. So many type of transformation we can do in seasonal also. Yeah. So we have performed this. So you can see like we have shifted our data by 12 in the sales difference column. So these are all null values, and here we have original data. So just we want to subtract it. So we can't subtract the null values and the integer. So we are dropping the not null, like null columns, and then further transforming it. Okay. So what we see, actually you can see it is p-value minus 2.83, which is less than 0.05, and we got stationary. Our objective is completed now. Means we have some type of seasonality over a period of time, like over a year. Again, similar kind of data is being repeated. So you can see here, now this type of data not seeing any pattern trend. So this is basically that random error values which I was talking earlier. So moving ahead, yeah, so this is auto correlation plot. What does this means? We want to see some type of correlation. Is there any correlation between the lagged values and between the lag value or the autocorrelation? Is there any correlation between them? Lag values means basically the shifting of the previous month's values has any like effect upon the correlation part. Just we want to see that here. Okay. So basically what we are doing it, we are importing that autocorrelation plot from Pandas plotting and plotting the just plotting a graph. Okay, so how to interpret this graph? So I have written some insights. So basically the x-axis it's saying lags. What is lag? So it's the number of period by which the data shifted. So we want to see like after how many shifts we are exactly able to see any such kind of patterns or correlation between that uh, autocorrelation and the lags. So y-axis contains the autocorrelation coefficient, which quantifies how much a time series is correlated with its lag values. So this is basically lag values means shifted values. Okay, so how it is related, like 1 to -1 we have like more correlated means near to 1 means positive correlation. Okay, so next we have is like autocorrelation. Yeah, past value I have seen you, and yeah, what is this confidence interval? So it's this dashed line. So whatever data we have is between, so like confidence interval is kept here as 95%, means 0.5%, 0.5% or 0.5 we have it here. What is 0.5? I'm saying so 95% we have seen in statistics. So 95% is alpha, and 1 minus alpha uh, is our correlated value which we want to see between the dashed line. So it represents actually the threshold. So this threshold says like beyond this threshold correlations are considered statistically significant. So like इसके बीच का जो data है वो significant नहीं है, but beyond this threshold we whatever we are seeing is actually important to us. So confidence interval is that's why set as 95%. We only left with 5% of data. 0.5%. So now how to make some analysis. So if any periodic lag अगर spike देखने को मिलता है हमको, like after this we are again seeing spike, then down, spike down, spike down, spike down, spike up, spike down. So we are able to see this kind of pattern. So it means stationary, we have a seasonality type of pattern. So otherwise we have some kind of more patterns like white noise, random walk. So random walk is basically our non-stationary type of pattern, and we have trends. So according to data we have to check which kind of pattern is actually showing from the ADfuller method insights. So once we are done with our correlation graph, so we know here that there are significant spikes up and down, so we know it's a seasonality kind of data. So moving ahead, there are two types of method. So using like ACF plots and PACF plots, and we want to see in the seasonal part we have these two methods. So if I can say, this is kind of ARIMA part. So in ARIMA we have like these three things: AR plus I plus MA. So AR is basically saying auto regression part. I is defining the integrating part, means the differencing part, and MA is basically indicating the moving average part. So in AR basically means auto regression part, we have this ACF plots, and like in our integrating part we have this PACF plots. Okay, so this requires basically some maths before it. Yeah, so now we want to see whether we want that PQD. There are PQD values. So P is for AR and I is for Q, and M is for D values. We want to check what QD values we actually want to keep. So this graph we got after this plotting. So how to interpret it? So for ACF plot we have like sharp drop after a few lags, means if we are able to see like this is the first value and we have at like it's exponentially decreasing, which we can say. So what is happening here, if there is a sudden drop after a few lags, means it's going down. So what we want to see, it's a stationary type of thing. So again we are confirming our thing, like is it stationary and any impact of the periodic lags or not. So spikes at specific lags, so just see if there is any, like I want to directly go to 12. So because it's our monthly data, so see 12, we have a significant drop at 12. Like earlier it was decreasing slow, but at 12 it crosses this threshold values. Sudden drop we are able to see. So means yeah, like it's a yearly seasonality. If we are able to see it at 24, means after 2 months, 2 years we are able to see that thing. So gradually decay, like if it decrease slowly and all, so it means like it's a trend or non stationary part, anything. So interpreting the PSF graph, it basically says that at lag 1, अगर हमको like we want to see a spike, we are able to see a spike, indicates कि जो AR है हमारा, it have a direct way, like the past values have a direct effect on the future values, means the past few months which we have directly impact on the future values, means there is some kind of repetition or some pattern or some cyclic pattern we are able to see, spikes up and down type of thing. And yeah, so these are from other. Yeah, so you can see 1 or 2 lag, if it suddenly drops to 0. Yes, it dropped to 0 after 1 or 2 lags, it suddenly drops. So we can say like 1 or 2 value of P can be 1 or 2 to calculate our ARIMA model. So yeah, okay, I explained it here also. So now we want to um, model our ARIMA model to have the forecasting part done. So firstly we are using ARIMA model, though we know like it's a seasonal type of thing, but we want to explain what's ARIMA model, how it is performing, so I am using it here. So ARIMA model is basically like AR PQ, I have already told here. So breaking it into pieces means AR is the like one leg of dependent variable. So yeah, AutoRegressive part, integrated and moving average part. So these have these variables in the mathematical formula, and currently we are keeping it as 111. So given the description, I've included like AR1 means one predictor is included from the previous data, which is called as lag we are doing, and I1, okay, how many times the data is being integrated or differenced. So we are only differentiated once only, and moving average, like one lag of the residual error is included as a predictor. This is some math parts, keeping the values like 1 1 1 comma 1 comma 1. So I know the detailed approach, and I can explain it later in later videos, like how actually we can decide what PQ or D value we have to keep. Currently we are doing it with 1 1 1, like by analyzing with these graphs and the ADfuller method and all. So once the model is like done, now we have to fit that model in our data. So what we are able to see, like you can see, we're able to see what's in summary. So this summary basically helps to define, like to compare between two models we have. Okay, so ARIMA model we have it here, and one on AIC. So we can see, like it's dependent variable is monthly beer production we have. Okay, 476 observations we have, and like we have this AIC. So this how like AIC and BIC. So ये जितना कम हो, like lower हो, it's more better for our model. Like so these should be like lower. So if we have another model, we have to compare, like if this is lower than that model, yeah, this is better, or that model's value is lower, we can say that this is better. So right. And next we have this coefficient, standard deviation, error, and part. Okay, more matches here only. We can talk about skew. Yeah, okay, so skew is like nearly zero we have, so this means like almost our data is symmetric only. Kurtosis, yeah, so like it's a normal type of distribution, like from this 3.3138 indicates only this, like it's a kind of residual distribution, kind of normal, like this type of thing. If we have visit what else? Yeah, so moving ahead, we want to predict now, like whether our ARIMA is going right or not. So what we have done is creating a model, creating a column. Forecast is its name, and what we want to do is predict from our fitted model. From the range, it's 467. You can see, like it's from the date we have after 467 to 500. We just want to predict. So yeah, so this monthly bear protection chart already we have seen. Yeah, this is there, and now we want to see how our model is predicting to this range. You can see it's performing nothing, because it's a ARIMA model and our data is like seasonal type of data, so it can't perform well. We need to have a model which deals with this season type of things. For that part, we have SARIMA model. So we are using SARIMAX here, and SARIMA model is basically for seasonal type data. So again, we are initializing it, and order PQD is 1 comma 1 comma 1 comma only 1, and this here is the seasonal order 12 here, indicating the number of periods in a cycle. Like after 1 year our data was like repeatedly moving, we can keep it 24 if 2 years, similarly 6 months or later, like what we want to do. So results is equals to model fit, fitting the model. So now we want to see like how our data is currently looking. You can see it's like this, and we have seasonal difference. Okay, and yeah, so earlier we have made the season difference in the previous steps, which I would like to see there. Yeah, where is it? Yeah, this is the part. So see, there's a seasonal difference plotting is here. Yeah, here we are done this seasonal difference part. This using seasonal difference transformation we are done. So once it is done, we have some values in it, and the forecast values are nan, right? All the forecast values are right. So once we have trained our model on the training data, now we want to test it actually with the testing data, like is it predicting right or not. So see, for our previously, like we have our data for 422 473. Now we want to predict for 422 423 is it fitting it right or not. So you can see kind of it's matching the pattern. Our model is able to see some type of pattern and able to match. So yeah, by more conditions we can like fit it more accurately. More mathematics can be used, more transformation can be used just to fit it more, but overfitting will lead in that case. So our model is currently performing really well. So moving ahead, if we like currently what we want to do is we want to predict for the future. So what we are doing is generating the future dates. So here what we are doing is importing the pandas dataset. Yeah, dataset type we are using. So this basically what it does from the previous last date we have, and we want to generate the next dates according to a pattern which we have. So what we're doing is in the future dates data frame. So index minus 1 basically means from the last date we want to add that date to the data offset next date. Yeah, so 0 to 24 means 2 year data we are taking. 0 month, 1 2 3 4, similarly months are increasing till 12, then the next year is started. So this column will basically give the next dates of 2 years. So you can see from this is actually 476th column. We have 475 columns earlier, and 476th column will be containing this type of dates later. Now what we are doing is concatenating our original data frame and this new data frame. So this will just stick below that of original data frame. So ऊपर original है, नीचे हमारा ये new वाला data frame आ जाएगा. So we have the nan values for that those particular dates. And now what we are doing is we are going to predict for those particular days what could be the prediction of those forecasting of that particular dates, like 2 years forecasting क्या होगी हमारी. So from forecast column we have this, and we want to predict actually from 470 till 475th we have the data. We have plotted our graph which is in the blue line, and this is the forecasted graphs like from 475 to 750. Okay, I predicted more. So to yeah, so this is orange line is indicating the prediction of that particular model. This is indicating yeah, for the next 2 years we have this type of prediction. So finally, yeah, we have achieved some of the forecasting. We can also like evaluate our model through RMSE. Like we can use RMSE error to get the difference between actual and predicted ones to evaluate our model. Like we can do those type of stuff here. So one more model is launched by Facebook, which is Prophet. I had implemented this also. So going straightforward towards, so just what we want to is pip installing Prophet. Somewhere it's in the documentation written, it's not installing directly. So I just use this %pip also, but mine in mine case like it works with the exclamation mark only, but I don't know like why it's mentioned there. Like, if not working we can use this also. So again yeah, importing Prophet as FB-Prohet. This especially I had done. I could directly import Prophet directly and use it. But recently in the newer version, after 6 months only, they have changed the naming convention. Earlier we have like import Prophet, then we have to do from FB-Prohet import capital P then Prophet. So this kind of thing they have changed now. Only Prophet contains the capital P and Prophet part only. So I had imported this as old conversion only like FB-Prohet, and we are using this plotly library, which are the auto plotting library of the Prophet, which Facebook has already given it. But in Windows 10 there is error, or there is some issues still raised by the like that model. uh, in their GitHub repository they have mentioned like for Windows 10 in VS Code, or in you are using Jupyter Notebook, it's gonna take a long time with not given end. For like some users it was for 6 hours when Plotly was not able to be installed. So this is the issue. Like over Windows 10 it might get installed early, but in Windows 10 it is not able to install properly. So I have suggested another method. So this is not working for me. So you can directly use, I had written the code also. If it works for you, you can use that code. Otherwise, I've made an approach. You can use that. So again, we are doing, so now creating a newer data frame, which is for again for our data set, and dropping the null values and reset the index. Okay. Next, getting some insight from the info, like describe also is there, and info describe basically statistics part we know, and here we can get directly for the data, what type of data type of that object, null values and all. So info we get it from here. Now getting the again the insight, which is similar to that only the previous ones. Yeah, this is the main step where we want to convert, where we have to a target column and the date column for the forecasting. We have to rename it to DS and Y. So DS basically contains the date and Y is the target variable like production and all. So FB-Prohet needs these particular values only, DS and Y. So we want to rename our column to DS and Y, and we have it here. So now we want to, yes, again convert into data time, and what again setting the index, yes, you know. Then we are again plotting if we are using individually profit and all. Checking the length, it's 476 only. Yeah, here we want to split our data into test and train for using the profit. So 25% I am using as a training data set, and 20 testing for is using that 75% data set. Initializing the FB-Prohet model. So this is profit.profit. You can see I have imported profit as FB-Prohet. So it is profit.profit. So it's kind of making confusion somewhere, like two other developers can make. So that's why I have imported as FB-Prohet, which was in the previous version. So now fitting the model with the training data set and making the future predictions. 100 months we have done, and MS basically month start. This is the alias which we are talking about earlier. So alias is month start. Each month starting date should be there. Okay, it start training, start process. It really works faster, very fast. In 2 seconds, I will train this 400 rows only. Now this is forecasted thing which we have. This is the result by a profit model. So we see the date time is there, but we have this trend. It calculates everything by just one click. Some mathematics is automatic process is there. So there's theory in the documentation what exactly each column means. So we have, and similarity. The main columns which I had seen is only we were in the seasonal type of data. We want to do this like y hat. Y hat is actually the predictions we have. So forecasting we have for the future dates, 100 future dates we have forecasted. So 100 is basically that period only for 100 months, you can say. It's done 1995 till, you can see, from 1972 till this 1995. Yeah, so I tried using Plotly and I had also done, but it's giving an error. Like Go is not defined inside Plotly. So that error is because Plotly is not able to get installed full by its own. So that's why the output is truncated, because I have to remove that output. I waited for 40 to 50 minutes, but it didn't work. So these were the two functions. If it installed in any of the system, you can use this part, and this is for plotting the components, and this is for plotting the graphs along with forecasting. What approach I had used in the previous, like how we used to plot in ARIMA and SARIMA. So what I've done is the converting the date time into, okay, what we have done, yeah, okay, yeah. So now this is the step-by-step process. If you convert the index or date earlier, you can face some error. So again, we have to convert it into the like date time indexing, and again, like similarly, we want to create future dates for the next 24 months, and again we are concatenating with our original data set, and then using that 475, you can see 4 till 475 to 800 I am making the predictions. You can keep this value like for how many periods your model is being get trained. So this is how I like after concatenating the original data set and the future data set, now we are able to like populate this. So this kind of orange is the forecasting through FB-Prohet. We are able to get this type of result. So this is again here also we can use evaluation RMSE and all to evaluate our model. So this is the project which I have done using ARIMA, SARIMA and FB-Prohet also. Thanks for watching. Thank you.